So for today then, we have chapter 5 and chapter 6. So chapter 5 deals with hearing. In terms of the structure of the ear, right? So the structure can be broken out into 3 major components: outer, middle, and inner ear. So in terms of the outer ear, which is basically going to be that part, so what is the purpose of the outer ear?
Catch the budget frequencies and stuff.
Catch the sound, right? And then direct it into the middle and inner ear, right? That's the whole purpose of this piece, right? Is to catch the sound and direct it into the other parts of the ear. Right? And then from this piece to where you get to the middle ear, you do have this canal. And what's the purpose of that?
To collect the sound, bring it into your ear.
Okay, so the outer ear is that. Why do you have that? Why do you have that spacing in between the outer ear and
To concentrate the sound,
middle ear? Right?
to direct it to one
Okay.
spot.
And part of it. The other part of the reason you got that there is just for protection, right? It helps to protect
The inner ear.
the inner ear, middle ear. Okay.
Because of distance or something?
Yeah. Well, yeah. And maybe you're not supposed to sit. So if you think in terms of the Q-tips, right?
Yeah, you're not supposed to use
You're
it.
not supposed to jam the Q-tip into your ear. Okay.
You know, there was a lady, an audiologist that came in and talked to us in one of our audio business classes, and she was saying not even to ever use a Q-tip, and ears naturally clean themselves out. And I just got to politely disagree. I mean, you got to, just a little bit. You don't need to go down into your damn inner ear, but just, you got to clean that gunk out, man. Because have you ever seen someone that hasn't cleaned their ear? It's like got a bunch of shit in it. It's nasty. So I don't buy it. It does not clean itself well.
You gotta do it, right? You just gotta make sure you don't jam the Q-tip all the way down.
Exactly.
Yeah, I used to get ear infections with overloading of wax.
Right. Same here. Exactly. I had to get tubes put in my ear. You tube it?
Yeah, so you think about, when you were a kid, that's a common thing for kids, right? You get the ear infections, and you moan and groan and cry, carry on. Mom and dad finally get tired of you, take you to the doctor, tell the doctor to fix it, right? Which is also part of the reason why we have one of our current medical problems, which is creation of superbugs.
Right.
Because of our use and overuse
Antibiotics.
of antibiotics.
That's correct.
Because barely you think about when you were a kid and you were moaning and groaning and crying. Well, mom and dad made sure you took the medicine every day because they didn't want to hear you anymore, right? But then the problem is you get older, and you get sick. You go to the doctor. The doctor says, "Yeah, you got this bug. Here, take this for the next week, 10 days, and you'll be fine." But the problem is you got to take it several times a day. And yeah, you're good the first few days because you really don't feel well.
Yeah, the pain.
But then you got to take it with you when you come here. You got to take it with you when you go to work and all that sort of stuff, right? So after a while, people get tired of that. And they're feeling better anyway. So they just forget.
Right.
Well, the problem is you
Didn't kill it.
kill off the weak ones,
Yeah.
the strong ones survive, and then you get to go on and infect the next person.
And then not only that, but you go back to the doctor a month later because the infection's back, and the antibiotics don't work anymore.
Right. And so, yeah, we barely have created bigger and better bugs. Okay. Of course, one of the worst places to be if you're sick is a hospital.
Absolutely.
You'll find out a lot of really good bugs there. After all, that's where MRSA came from.
Define good.
Came out of hospitals. Yeah. Hospitals create these things. They're used. Okay. Right. And then, of course, the other problem now is you have where mom and dad, mom especially, will clean everything in the house. You get the Fantastic, you get the 409,
Right.
you get the Pine Sol.
Oh, don't forget the instant hand sanitizers.
Right. Yeah. And we clean everything now to death, okay? And then you wonder why Johnny keeps on getting sick. Well, because Johnny's immune system never had a chance to develop.
That's exactly right.
Yeah,
That is very
because
true.
you develop by being exposed to things, right? And there actually have been studies where they compare immune systems of children who live in the country compared to those who live in cities. And because kids in the country, because not only they play in the dirt and on in terms of family farm and the animals and all that good stuff, their immune systems have grown stronger. Okay. All right, well, anyway, back to the ear. Okay, so you got the outer ear, which badly collects the sound, brings it into the ear canal, which then passes it into the middle ear. Which is where you find like the three smallest bones in your body. Hammer, anvil, sternum. Okay. Those are those three bones. Okay. That signal is then sent into the inner ear. So there you got that physical vibration of the eardrum, passes that signal to those three bones. Those three bones then barely tap out a signal into the inner ear. So you got the actual physical vibrations are then barely changed into an electrical signal, which are sent to the brain. And you get to hear whatever is coming out. Okay. So it turns out, I have a little video that goes through that whole process.
That was just an ad. That was amazing.
Many of us take for granted a very extraordinary organ, our ears.
What was that?
To understand the ear, we need to understand what sound is. The speakers you are listening to right now are vibrating, flexing in and out, causing a wave of pressure through the air. The frequency of these waves, or the speed at which the sound creating surface moves back and forth, affects the pitch of the sound. The level of air pressure in each wave is directly related to how loud the sound is. The outer part of our ear catches these waves. It faces forward and has a specially designed structure of curves helping us to determine the direction of the sound and also emphasize the frequencies used in human speech. Now that the sound waves are caught, they travel through the ear canal and strike against our eardrum, a thin membrane about 10 millimeters wide. Now that we receive the sound, the middle ear transfers this energy. The smallest bones in your body, the malleus, incus, and stapes start in motion. The malleus is attached to the eardrum, and as the sound travels along, the force is amplified by leverage until it arrives at the stapes, which acts like a reverse piston, creating waves in the fluid of the inner ear. The most significant increase in pressure is caused by pneumatic amplification. The face of the stapes has a surface area of about 3.2 square millimeters, while the eardrum has a surface area of 55 square millimeters. Using this, along with leverage through the malleus and incus, the final pressure is 22 times greater than when the sound first arrived. Now we come to the most complicated part of the hearing, the cochlea. In reality, it is coiled up, but it is easier to understand straightened out. There are actually 3 chambers inside, but let's take a look at the central part. The stapes is causing pressure waves to travel through the structure. Along the inside wall is about 20 to 30,000 reed-like fibers. As the waves move along, they encounter fibers with the correct resonant frequency and energy is released. These fibers aren't actually what give us the signal that we heard something. There is a special structure next to these fibers containing hair cells. When the fibers resonate, they cause the hair cells to move, which then sends an electrical impulse to the cochlear nerve and onto the brain. Certain pitches of sound will resonate in specific locations, and louder sounds will cause more hair cells to move. Our brain interprets all this raw data, making it possible to enjoy things like music or an engaging conversation. Just to think that all of this is happening in your head right now at full speed. This is just one of the amazing systems found in the human body that go far beyond our humble human understanding.
So you have in terms of the outer, middle, and inner ear, that each one do. Outer ear collects the sound. Middle ear rapidly transfers that signal into the inner ear, and it's the inner ear and those hair fibers, which then they transfer the signal to your brain.
Michael?
Yes.
Speaking of sound, the video that you posted last week, the sound on it was really, really bad.
Really, really bad.
Yeah, like I could hear like the room and like everything behind the camera like a lot more than you.
Whoa, okay. For which class?
For I think it was this class.
I think you sent an email to us, right? Yeah, sent us an email letting us know.
Well, I'd like to know it's up, yeah. But I also teach him. He's also in my trade class, so. Okay. All right.
I didn't check out the third one from last week, but
All right.
this one was.
I noticed it too.
Okay. All right. Okay. So you then had in terms of this report. I can't use it a little bit.
Just can't seem to escape another season, eh? You may be running through allergies. Don't get caught off guard. Try new Zyrtec Dissolve tabs. Powerful allergy relief now in a tablet that starts dissolving instantly. New Zyrtec Dissolve tabs.
And they own a little more of your mind.
Story affecting every American family. Here's the question. Are your earphones ruining your hearing? Right now, tonight, are millions and millions of Americans walking around listening to music but ensuring they will not be able to hear as well in the years ahead? Tonight, the mayor of New York says it's time to send out an alarm, and ABC's chief medical editor, Dr. Richard Besser, is stepping in.
30 years ago, people in their 20s could all hear the rustle of leaves, the drip of a raindrop, the babble of children. Now, for 1 in 5 of them, those sounds are gone forever.
normally people were coming in their 50s and 60s with hearing loss, and now that has shifted into people in their 30s and 40s.
In fact, Dr. George Alexiades has to tell more and more teens their high-pitched hearing is already gone. Designer headphones are big business, high-ticket must-haves. But for hearing loss, earbuds may be the most destructive. Some context. Music devices can produce about 115 decibels of sound. Earbuds add 5 decibels more. 85 decibels is where hearing damage starts. Power tools, 98 decibels. A lawnmower, 107. A jet taking off 100 feet away, 140.
Can I talk to you for a minute?
So how loud is the music? I went out with a decibel meter.
Coming in about 95. 105.
Whoa! 109. Here's what happens inside your ear. When strong sound vibrations hit your ear, the problem deep inside the cochlea are fragile hair cells. They turn vibration into sound messages to the brain. Blast them with loud sounds, and some wither. If the loud sound is brief, they recover. But if it lasts too long, or happens too often, they die. And they never grow back.
If you get to 100 decibels, I would limit that to about 1 hour a day.
My advice? Never go higher than 3/4 of your top volume. And a couple of hours is enough. Dr. Richard Besser, ABC News, New York.
That's pretty alarming about the more than 5.
Well, yeah, you think of it. Well, again, you you get on the Metro bus, right, or some transit bus, and you get the people on there who have the earbuds and headphones in there, but they may be way at the back of the bus, and you're in the middle or forward,
This one
and
goes
you
out to
can
all
still
the
hear the
allergy
noise.
members. You know who you are. You've become deaf to the sound of your own sniffling. Your purse is starting to look more like a tissue box. You can clear a table without lifting a finger. Well, modular.
Okay. But, so you have that going on now that, you also think in terms of people in their car with the bass all the way up, the car rattles, the windows rattle.
Now the reason,
Morning!
it's been a while since I took the audio tech class, or audio 101 or whatever. But is the reason people lose their high frequencies first because those are closer to the outer part of your ear, in the cochlea, and it goes high frequency, whereas
Yeah, the belly's all placed,
right.
Yeah. But yeah, so there's, after all, you think back in terms of all the old 60s and 70s rock bands, a lot of those guys are basically deaf, after all these years.
Keith Richards.
You know
what's amazing about that guy is he hasn't aged at all between the age of 40 and 75. He looks 75 at the age of 40, and he looks the same.
Yeah.
That guy's
Yeah, some of those guys, it's amazing that they're actually still alive.
It is. Rock and roll.
But yeah, if you think in terms of, if you are using earbuds or whatever to listen to your music or whatever, he said, turn it down. Don't have to have it all the way up. Because after a while, if you keep on doing that, you're not going to hear the music anymore, right? They said. So yeah, the number of younger people now that are having hearing problems has greatly increased.
He said in the short video that you're getting more hearing damage by using the earbuds instead of over ear. Do you know why that would be? Just because the distance of the speaker to the
Probably
drum?
pressure too. The inner ears inside your canal.
Right, it's inside the ear canal.
Yeah.
So it's causing more pressure, whereas the other ones are open.
Yeah.
That's what I
Yeah.
think. Sorry.
Right, and then so the thing is, people who use earbuds probably tend to play it louder because they don't have that other
The noise
Makes sense.
canceling.
sort of, and you don't have a little, plastic, padding there that sort of helps. If you don't have noise canceling, they help filter out some of the outside noise.
Yeah.
Right? But yeah. Like I said, the earbuds add 5 dBs to the sound. Which is a bit. Yeah.
Why is life so hard? I Instagrammed twice already today, but I really want to Instagram again. Is 3 too much? All the cereal bowls are dirty, but the maid doesn't get here for another half hour. I wish this chair was softer. It's so firm. I bought daylight bulb.
You cut us off.
Yeah, we don't want to listen to it.
Why is this guy so blue? Have you seen that Thanks Obama one? It's this girl, she's just like, thanks Obama. My breakfast sucks this morning. Thanks Obama. It's like, people love to play on. You know what I mean? It's ridiculous.
So then you get in terms of things like this, some online version of a hearing test.
It's gonna be a joke.
Huh?
I see, it said something going on here, like a trick.
Well, again, this
I
is
saw
not the way to actually test your hearing. because
Okay, it's not gonna be like a.
It's not a real, it's not going to be an accurate version of it, okay?
Is it still muted?
Yes,
it is.
Yeah.
No, I can hear.
It gets up to like 300 hertz and we're like still not hearing anything. There we go.
Well, it's into if you're getting a lot of pressure.
Yeah, now you, okay? So it steps up all the way, through the process here, okay? But again, it's not going to be fairly accurate in terms of it, but job you want to do, you actually need to go in and they put you in the chamber, keep the sound out, put the headphones on you, and then check your hearing. So one of the things, if any of you have a Costco membership, you can actually go to Costco and get a free hearing test. So you can check your hearing and see how you're doing. So decibel scale. Right? So anywhere from the threshold of hearing, so up to pain, right? So in terms of Seattle Seahawks and Seahawks Stadium, we do hold a record for the loudest crowd noise.
143 decibels there? That's not 141.
Yeah. What? Well, we hold a new record at the moment, right? And it came in at?
I think originally it was like 135, and then recently the Chiefs took it back the next
And then
day.
we went, now we beat it like
I think we're at
137,
I think we're at
138.
141 now, actually.
Okay. And so, yeah, we're up here at the 130, 140 mark for Seahawks Stadium for the loudest crowd noise, which is up past, up near the whole threshold of pain area. Which is why when they talked about, when they were talking about, going back to set the record, and you had that, you should be bringing some ear protection while you're in the stands, so you don't lose your hearing due to all the noise going on. The other thing they talk about in the chapter everybody's probably already seen the ear stuff many times, okay? But the thing they do talk about in the chapter, and if you try to get into the next chapter, and that is logarithms. The decibel scale is logarithmic. Okay? So decibel scale is logarithmic. pH scale, think about it in terms of acid and bases, is logarithmic. Earthquake magnitudes. That scale also is logarithmic. So logarithms. So for example, on the toy or the app, and again, if you are using an app, you do need to have an app that does do logarithms. Okay. So on the toy, what is the log of 10?
Is that a 1? Yeah, it should be.
Yes, Haley?
It's 1.
It is 1. It is. Okay? What is the log of 100?
10.
That will be 2. Okay? And then the log of 1,000 will be 3. Okay? So what I ask you to find on the calculator, well, logarithms give you exponents. So basically what I want to know is 10 to what power is 10? 10 to what power is 100? 10 to what power is 1,000? So that's why you got the numbers 1, 2, and 3. So you get in terms of logarithmic scales. Right? So if you think in terms of around here, we are in an area that is prone to earthquakes. There is, even though on the magnitude scale, if you say someplace had an earthquake of magnitude 6, another place had a magnitude 9 earthquake, 6, 9, hey, it's only 3 units. Can't be that much bad. Worse than it was. But because it is logarithmic, the difference between a 6 and 9 in terms of energy is that a 9 would be, in terms of energy, 1,000 times greater. Due to that. Okay? between a 6 and 7, it's 10 times greater energy. So, right? So logarithms. So the next chapter then deals with decibels and decibels. So you get in terms of the sound power level. SPO, yes. Right? And that's given by L sub W equals 10 log over W over W naught. Where W naught is basically in terms of the initial threshold of hearing, and W naught in terms of value is 10 to the minus 12. And that would be in terms of watts. So you get a question like this. What would be the sound power level given that W is equal to 0.15 watts. So in terms of my calculation then, we got that L sub W is going to be 0.15, sorry, 10 log 0.15 over 1 times 10 to the minus 12. So you plug that into the toy, or out. And you end up on the order of, to the nearest whole number, got a number.
Trying to figure out how to plug this in.
Oh, yes.
Why on the bottom is it 1 times 10?
Or you can just do 10 to the minus 12, whichever way is easier to plug it in. It is 1 times 10 to the minus 12.
112?
112 is correct.
If you're in the next break, can you like show me
Yeah.
You got one like mine, right?
how to? Yeah, I think so.
Go, all right, clear it out whatever you got in there.
Yeah,
Clear?
that's
Go 10
Yeah,
log
right.
0.15 divide 1 EE, second function,
That's the ticket right there.
right above the 7,
Oh, gotcha. Okay.
So you press
negative
twice.
12.
Just once.
Okay, so it's only
Close your
show
parentheses,
Okay.
equals.
1E, negative 12. How do we do a negative?
111.76.
So 112 is correct.
Okay, cool.
111.76.
Yeah. So again, the nearest whole number you get that this will be 112 dBs.
I
Right?
thought I was supposed to type it in the log of 10 and then, okay.
Yeah.
Okay?
I hear you.
All right. Okay. So yeah, not only a good thing is it to have the toy and the app, it's also a good thing if you actually know how to use the toy or the app and get the right number to come out. Okay. Right. So we got, in this case, it's going to be 112 decibels. So in terms of sound power, okay? And actually I was wrong. SPL would be sound pressure. Right, yeah, that power. Okay. Right.
I'm getting 101 every time.
101?
Yeah.
Every time, no matter what you do, huh?
I've tried it 3 different ways now.
How are you asking for your answer? Are you just pressing enter?
Yes.
Because sometimes we'll calculate it.
SCI220.
Yeah, I found go second, and I'm sorry, that diamond button. Do you have the green button? Then there's an equal sign above the enter.
Okay.
So that's what I found matters. Try that. It's like a mode or a function button.
Got it? Okay. All right.
I was missing the 10 in front of the log because it's in the log base.
Yeah, and there's nothing there for when you write log, it says automatically base 10.
Yeah.
I don't need to type that in. That's what the LOG button is, automatically on the calculator. Right? All right, so we get, in terms of this one then, on the order of 112. Right? Figured it out, Cody?
No.
Maybe. No?
No.
Alice? No? So on your toy, whatever you got in there, clear it out for both of you. One last time, all right? So got it all cleared out? All right, 10 log, which gives you an open parenthesis on both of your calculators, right?
Mm-hmm.
All right. 0.15 divide 1 EE negative 12 close parenthesis equals.
Mm-hmm. So the 1, is that like half of the 10, or like where's the 10 to the 12?
10 minus 12 is the same thing as saying 1 times 7 minus 12, right?
It's just a scientific way.
Okay, so the E is representing the 10?
It represents the times 10.
Okay.
Scientific notation is already built into the toy. That's what the E button is for. Okay?
Okay.
Right?
So it's all you got to do is press E and then negative 12.
Right. So that's already built in.
Did that work for you, Cody?
Yep.
Cool.
All right? Okay. Right.
Go for it. I'm gonna say mine don't have a
Uh-oh. Right, Mike? Need these. All right, how are you? Now that's not E. Well, no, I need the X there, which would be, what? That would be the X, is what I was done that with. But maybe you could try it, see what it does. If that doesn't work. No, E to the X is not.
E to the X would make it so good.
Right, E to the X is not. And so, yeah, so you notice you can find a scientific calculator app. Better one than that. Okay, all right. Sound intensity level. So now you get L sub I, 10 log I over I naught. Again, I naught is in terms of the threshold of hearing. And intensity,
So it's the same equation.
basically,
Just using I instead of W.
just I. So now it'll be in terms of intensity. Intensity then, in terms of units, for both I and I naught. Therefore, the answer we get out still will be in terms of dBs. Okay? Well, the units on I and I naught are now going to be watts per meter squared. Okay? And I naught will be 1 times 10 to the minus 12 watts per square meter.
So we have to figure out that first.
Well, no, that I naught is that number. Just like in the last equation. Because again, everything is done relative to the threshold, which is a constant. Okay? So, for example, then, in terms of this equation, which is fairly, whoop,
I'm just asking if you could stay there real quick. I'm just finishing the.
okay.
Thank you.
So really, this equation really isn't any different than the previous equation. Okay. Again, the answer we get out will be in terms of dBs. Okay. And so, given that the sound intensity, okay, so given that I is equal to 1.7 times 10 to the minus 4th watts per meter squared, what would be the sound intensity level? And again, that number will be in dBs. And yes?
So it's the same equation for full mode?
Yep, it is.
Okay. I'm a little bit lost here. Are we supposed to plug, we're supposed to substitute the I in the numerator
So
as
I
well as the I in the denominator?
equals 10 log, in this case, 1.7 times 10 to the
Okay.
minus 4
That answers my
over
question. Thank you.
1 times 10 to the minus 12. Okay? So you plug that into the toy, and the answer to the nearest whole number is how many? 82. 82 is correct. You should end up at 82 dBs when you plug that into the toy.
So again, we're just gonna go 1 EE, right?
For the bottom number, yes.
Okay, instead of doing 1 times.
No, again, that's what your scientific note, that's what that key is for.
Okay.
Takes care of all that for you.
So could you tell me, like you did the last one, plug
Step
this
by
in?
step?
Yeah.
All right.
So I'm just still, the EE thing's really fucking me up, because number 1, it's EE, but when you push it, only 1 E shows up.
That's all you
so
need.
two
You
of
only
them.
need one.
But it should be called E.
All right, so you ready?
Yes.
All right, 10
Okay.
log, which gives you an open parenthesis, right? If not, put one in. 1.7 EE, -4. divide 1 EE negative 12 close parenthesis equals and to the nearest whole number you end up at 82. Huh?
Yeah, 82. All right.
Haley.
Yes.
Yes.
Oh, never mind.
Okay. Yes.
Can you scroll up a little bit to the top of the page, please?
Sure. Oh, yeah.
Thank you.
All right.
Wait, did you write dB for 82?
Yes.
Yeah.
I thought it was
I think you might actually
watts
be able to
per.
do it.
Now, the units on I and I naught are watts per meter
Is this
squared.
clear?
Okay.
The answer we get out, however, will be in terms of dBs.
So what is, just a quick question. On his, he's using an app, it's a science, you know, it has notations and whatnot. But there's one button that says log, and then there's a 10 on the bottom, not the, would that, okay. That might just be log, bro.
Probably just log.
Oh, yeah, actually, it is. You know what it is, it's log 10, because it gave you the answer for it. I don't think it is log.
Yeah, okay.
So you remember
All
how
right.
it was before log?
So in terms of up and down and all that good stuff. Okay. Right.
And then one shows up.
So Cody, why are you had a couple of, can you look and see in terms of when I'm up here talking in the screen where the sound bars are going up to? So and there it is. You should be able to see in terms of sound level.
Mm-hmm.
How far is it going up?
Pretty much all the way.
Okay. All right. Should be okay. Hopefully. Right? All right. Everybody have that? Everybody got the toy to work? The app to work? Yes.
One more question. So to find the intensity, you need one. You need one or the other. You need the intensity or the intensity without.
Now, if I wanted to find the intensity, let's say I want to actually go the other way, right? That's your question.
Yeah.
All right. So let's say I know what the dB reading is, right? I want to know what was the intensity of the sound. Okay. So now that is going the opposite direction, right? So we had L sub I equals 10 log I over I naught, right? 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 So we know that we got our reading. We said it was 82 dBs, right? Right? So let's go backwards. So what is the sound intensity if the sound intensity level is 82 dBs. Okay, that's exactly what you're asking, right? I want to know what I is, given I know what the dB rating is, right? Right? So I naught is I naught. That doesn't change, right? So let's plug in our numbers. So we got 82 is going to equal 10 log I over 1 times 10 to the minus 12. Right? Yes?
My question is, earlier we were talking about how log 10 equals 1, log 100 equals 2, log 1000 equals 3. Is log 10 the same as 10 log?
No, 10, what, the 10 out front?
Yeah.
That means 10 times.
10 times log. Okay.
Barely the reason, all right? And barely the reason why we do the 10 out front, because look at the numbers we're talking about. Intensity levels are 10 to the minus 4 and that sort of thing.
Very small number.
Very small numbers, right?
Or large, if we're talking.
Which means, if you do the log of 10 to the minus 4, okay?
I got negative 100.
Yeah. That's pretty good. For what, the one we just did?
Yeah, for that.
We haven't done anything with this yet.
Oh.
Okay, okay. All right. multiply it, the only reason why we multiply it by 10 really is to make it on a scale that we can make it easier to deal with. Measure by the 10 out front. It makes it numbers that are reasonable for us to think about. All right, now the question here was, how do I go about backwards, given that I know that it was 82 dBs, how do I find out what I was? Okay? Because I naught is I naught. So I want to take this equation and I want to solve it for I. So first off, this says 10 times the log. What is the opposite of multiplying? Divide. So we're going to divide by 10. We'll divide this by 10. We'll divide that by 10. What is 82 divided by 10? 8.2. Everybody should have been able to do that without using the toy, right? Say yes, Haley. All right. So we get 8.2 is going to equal the log of I over 1 times 10 to the minus 12. Okay? Now again, the way we do things in algebra and solving is always to do the opposite operation. So it's easy in terms of adding, subtracting, multiplying, dividing, knowing where the opposite is. But now we got log. And how do I get rid of the log?
The E.
Okay? Okay? So in terms of that, what I'd like you to do in terms of the toy and or the app, if possible, is tell me the answer to this. What is the log of 10 to the 5th? What? You will get 5, right? You try doing the log of 10 to the 5th, you find out that the answer will be 5. Okay? Now, on the toy, what is the 10 raised to the log of 5? Try that on the toy. 10 raised to the log of 5. Okay.
I get 5 again.
I get 5 again too. Right? So log and 10 to the x basically are opposites of each other. They cancel each other. So if I want to get rid of the logarithm of that, in terms of my process here, we now get that this is going to be 10 to the 8.2 is going to equal I over 1 times 10 to the minus 12. Right? And then the opposite of dividing these two, multiply. And so I is going to equal 10 to the 8.2 times 1 times 10 to the minus 12. You plug that into the toy. You end up, given our numbers, you end up at 0.00016. Yeah. Again, it doesn't give it to you in scientific notation because on your calculator probably, because your calculator, if it has space, will print the number out. Okay? So this will give you a value of 0.00016, and then this would be watts per meter squared. And again, we're off a little bit from my first number just because we did round a little bit, and then we said 82, not 82.3.
Watts per meter squared.
For the value of I, yes.
That's interesting. So like two-dimensional electricity, like is it on like a plane? How does that work?
Barely in terms of, because if I have a speaker,
Yeah.
the sound is going out in terms of, it really is going out in terms of all dimensions, right?
Okay. That's interesting.
Right.
I can't get that answer.
You can't get that answer. Okay.
Can you go up just a little bit on your question, please?
How far?
That's good.
All right. Okay. So 10 and log, 10 to the x and log are opposites, and that's how you get rid of them. Okay. Again, we're off a little bit because we use 82, not 82.3, which is what the real number was. So that's why we're not getting 0.00017. Okay. Right. Now, intensity of sound, intensity of light, intensity of gravity changes with the distance between the objects. For all of them, the relationship is the same. Okay. You have, everybody got all this before I change page? Okay. So the intensity So the intensity falls off with the distance squared. Right? So, if I double the distance, by how much does the intensity decrease?
Squared.
Which means, so by how much does it decrease? If I double the distance,
By half.
I have.
By 4.
Very good. By 4 is correct.
How did you figure that out?
Because it says it falls off with the distance squared. What's 2 squared? 2 squared is 4. Okay? So if I increase, I start out with 1 point, and then I increase the distance by a factor of 5, how much does the intensity decrease?
25.
By a factor of 25, right? 5 squared. Right? So the intensity then, I, in terms of sound, and given that the sound is actually, think in terms of, I have a sound source, it's going to be going out in all directions, so basically in terms of a sphere. And so the intensity is given by W over 4 pi R squared. W over 4 pi R squared. So if I have a speaker, okay, in terms of this, okay. And so I got, what is the, so if W is 1.3 watts and R is 5 meters, what would be the sound intensity level. So I will be 1.3 over 4 times pi. Better. 4 pi, and this would be 5 squared. You should be ending up on the order of
0.0041.
0041, and this would be watts per meter squared.
Which signifies intensity?
Yes.
Okay.
So the intensity changes with the distance. The further away you are from the source, the lower the intensity, right? What?
I got 25
What? Okay. So the intensity of sound, the intensity of light, the intensity of gravity changes with the distance.
Makes sense. Is this? I like to think about things like real world perspective. You know, like practicality wise. Are you saying that sound changes also with like this? Okay, can you explain that in terms of? I know something dropping from a building, right? Like Newton's law.
Newton's law, yes.
Okay, it increases, speed.
Right.
With distance.
Okay.
How does that relate to sound?
Well, so here we're talking about intensity of the sound.
Okay, so
how valuable? So you think in terms of if I'm here and you're there and I'm talking, right?
Right.
But if I'm in this room and you're down to the other end of the hall,
it's decreased exponentially.
Right.
Okay, makes sense. Thank you.
Your ability to hear is not going to be that great, right?
Okay.
Which is why you actually have to come into the classroom if you actually want to hear me speak.
Or I can watch your video online.
Yes.
I've tried it multiple times and I keep getting 25 points.
Okay. So again, in terms of the toy and/or app, and as I've mentioned several times before, if you have multiple operations going on in the numerator and/or denominator, you need to use parentheses. So, do 1.3 divide, open parenthesis, 4 pi times 5 squared, close parenthesis, equals.
I just,
Whatever. Whatever.
I think it'd probably be easier if you actually did the whole thing parentheses. Especially for future reference, like when we go look back at it, we'll just think nothing of it.
Yeah. Yeah. I can next parentheses all I want, but okay. Well, like I said, I've mentioned several times, again, if you got multiple operations, you do need to use parentheses because the calculator needs to know that you want to divide by all of this as one number. If you don't put in parentheses to the right spot, your calculator just does order of operations, which gives you a totally different answer. Okay? All right. So the intensity changes with the distance. Right? Similarly, then you get in terms of questions dealing with this stuff, and in terms of like the homework, and in terms of like the next, when we actually have the next test, I can give you a question where I say, okay, what will be the sound intensity level given that we have whatever somebody's planning to have 1.5 watts and you are 10 meters away. So the first part would be to actually calculate I out at that distance. take that number and then plug it into that equation, 10 log I over I naught, to actually get the answer. Okay? So in terms of those two together. And so the next one then, which you asked about, and that was in terms of sound pressure. And so you get in terms of this one, and then there is a relationship between the intensity and pressure, and you also have that the intensity is related by that. And in the book, they say you can make an assumption regarding the value of this number. And so they say you can assume that this is going to be 400. Is the assumption. So P is the pressure. Okay. And actually this would be more of a script. That fancy P is the density of air. And C, which is weird because they use C, a little different context what you normally think of. C here is the speed of sound compared to Einstein's use of C, which was the speed of light.
So we're still using I for intensity when
right.
We're looking at pressure?
Right. So there isn't a really pressure relates to intensity by this equation. Which means if I know the intensity, I can find out what is the pressure. Okay? So if I take this equation here and I solve it for this. Okay? So given the assumption that rho C is 400, we would have I equals over 400, right? And if I am solving for the pressure, we got that the pressure squared is going to be 400 times I. Because again, the opposite of dividing is to multiply. And then the opposite of squaring?
Square root.
Square root. So the pressure is going to be the square root of 400 I. Right? All right.
We might going up once.
What?
Just go back up a little bit. Wait a minute. Let's do more time.
How far up?
It's right there. Perfect.
All right. Yep.
So it wasn't P2 equals square root over 400, just P equals square root.
Well, yeah, when I get to the main, and I'll go back down, but yes. Because the opposite of squaring is to find the square root. Okay?
So is that the final answer, the square root of 400i?
Right.
We can't go anywhere.
Right. And so again, once you know numbers, all right? So again, you go back to my question dealing with the speaker. Okay? 1.5 watts. 10 meters away, you can calculate that. I can get this number. Once I know that number, I can calculate the pressure. Okay? Okay. And once I know that, again, going back up to my original equation here, this number is 2 times 10 to the minus 5. Okay? And that is in terms of newtons per meter squared. Again, it's pressure, which is the amount of force per unit area.
That's a constant? Yeah.
That's a constant, yes. Just like our I naughts and W naughts we had. Okay. Right.
It's called, when the zero's in the lower right corner, it's called something non.
Yeah, not. So P naught. Yep. W naught. I naught. Okay. Right.
Excellent.
So if I have, in terms of a saxophone, trumpet, whatever, and it's playing away at 75 dBs, we then have 5 saxophone, trumpets, each of them playing at 75 dBs. The level will now be how much? So if one is 75, let's see, so 5 at 75, let's see, that means you're going to be up to what? 375 dBs?
Negative. That is not the correct answer.
No, you don't think so? Right?
That would be a scary world.
That would be a scary world, right?
You know.
We wonder that Better Royal Hall will still be standing, right? all those guys that are playing away.
To 150 dBs listening to 2 trumpets.
Okay. All right, so yeah, it doesn't quite work that way, right? That if one is 73, is not going to be 210. Okay, which is probably a good thing. Right? Wouldn't be able to have much of an orchestra then.
Year would have evolved.
Okay.
Perhaps. You're right.
So basically it comes down to, in terms of that, is, so in terms of multiple sources, initial is plus n okay. So the initial decibel level, what it is for the one, and n then is how many are playing. So, example, if I said that the first one was at 75 dB, and I have 5 of these, what will be the output? Well, it's going to be 75 plus 10 log of
82 decibels.
How much?
82.
82?
Yeah, it's 75 plus 10 log 5.
Right.
Yeah, so it's actually 81.9897.
So 82. Right? So the
So
output,
yeah, clearly it's far different than
having 375 dB,
Yes.
right?
Yeah.
ahead.
No, but you know, I do remember like some of the initial audio classes. I was a little surprised to learn that, you know, when you're first learning about DV level, you would naturally think that they're going to double in sound. You know, but it's, yeah.
Right?
Yep.
With that, let's take a little break, take like a 10-minute break. When we come back, there will be a test.
Uh-oh.
It is open book, it is open notes, it's not open paper.
Oh, Professor.